Good morning, guys. We are going to start our last unit of the year. We're going to get into some trig. You've seen some trig before in geometry when you learned about sine, cosine, and tangent. And you learned about angles and the ratio of different angles to different sides. I'm going to introduce something new to you today. And then this will get taken a lot farther next year in Algebra 2. So we're going to talk about this idea of angles and how we can measure them in degrees or we can measure them in radians. And I don't think you've ever heard of radians before. But it's the idea of, if I want to measure length, I could measure the length of something in inches or meters or centimeters or feet. And so I can measure angles in two different ways: degrees, which you're used to, and then radians, which I'm going to talk about today. So, first thing is on this page, we have this idea that if we have a positive angle is going to be denoted by going counterclockwise. So counterclockwise would be going that way. Negative angle is denoted as going clockwise, which would be this way. Angles, we often use Greek letters to represent angles. So like X, Y, Z, those represent sides, but we're talking about angles, we're going to be using Greek letters. So if I have a 46-degree angle, negative 46-degree angle, I'm going to start, my initial side is always supposed to be on the positive x-axis. So my initial side should start here. And if I have a negative angle, I'm going to go clockwise from there. And I'm going to estimate about 46 degrees, maybe something like this. So this right here would be a negative 46-degree angle. The negative is just indicating the direction that I'm going is clockwise. 135 degrees, again, I would start from the positive x-axis. But now that it's a positive angle, I'm going to be rotating counterclockwise. And 135 degrees, straight up here is 90. And 135 degrees is 45 degrees more than 90. So that would put me like right about here. So I rotated counterclockwise. 90 plus 45 more will get you at about 135 degrees. Okay, I want to show you some common angles here. So you might want to pause this and copy this diagram down. But this is just showing some popular angles that you're going to see. So this is going every 45 degrees around the circle. So 45 is half of 90. And we know a 90 degree is a right angle. 45 degrees is half of that. So split that right angle right in half. So I'm going to go every 45 degrees. 45 plus another 45 is 90, plus another 45 is 135, plus another 45 degrees is 180. 45 degrees more puts you at 225. 45 degrees more puts you at 270. 45 degrees more puts you at 315. And 45 degrees more puts you at 360 degrees. So 0 degrees and 360 degrees are the exact same thing. They both represent straight out in this direction. I can split this up into smaller chunks too. I can go by 30s. So here's going every 30 degrees. So you might want to pause this and draw this picture. These are popular angles that we're going to be using as well. So adding 30 onto 30, you get 60. Adding 30 onto that, you get 90. You just keep adding 30, adding 30, adding 30 until you get all the way around the circle. So this might be kind of helpful to have drawn. So degrees are in general pretty easy for us to visualize and estimate. Where it gets tricky is with radians. So I'm going to demonstrate what a radian is. Okay, so I used to do this with Smarties or M&Ms, but I would take and I would draw a circle and I would make the radius 7 Smarties worth. 1, 2, 3, 4, 5, 6, 7. So this radius is 7 Smarties. And what I'm going to do is I'm going to take this radius and I'm going to wrap it around the circle. So imagine taking each Smartie and placing it along the edge of the circle. And I'm going to measure out 7 Smarties worth. So that's what 7 Smarties worth looks like. This is 1 radius. So I took that length of the radius. Imagine if this was string, and I cut the string, and then I wrapped the string around the edge of the circle. So this is the length of 1 radius, and that is called a radian. So it is 1 radius wrapped around the edge of the circle. So that's 1 radian. So you might imagine this right here, if this was a pizza, what would be this angle? So you can kind of make a guess. Why don't you just kind of formulate a guess in your head about how many degrees you think this is. Okay, so that's 1 radian. If I continue wrapping these around, so now if I were to move these and continue wrapping them around, it would look like this. So remember, this was 1 radian. Now this is 2 radians. So here was 1 radian. Here's 2 radians. Okay? And then if I continue wrapping them around, here's 3 radians. So this mark right here marks 3 radians. And do you see how that gets me almost halfway around the circle? Almost. Little tiny bit left over. And that little tiny bit left over is 1 of those circles. So we would have found out that this is 1 of those Smarties. So again, here's 1 radian. Here's 2 radians. Here's 3 radians. And then this little bit right here is 1 out of the 7 radians. Remember how, like, if I go back, each group was 7 Smarties. So this is 1 out of the 7 in the group that I had that measured 1 radius. So half of a circle is 3 radians. 3 got us to here. 3 radians got us to here. 3 and 1/7 radians. Now, if you have your calculator, type in 1/7. 1/7 is 0.14 ... So this is 3.14 radians. Half of a circle is 3.14 radians. Now, hopefully you recognize 3.14 as a special number. That is the same thing as pi. So, half of a circle Let me draw a little picture here. Half of a circle, starting here and going halfway around, that is 180 degrees. Half of 360 is 180 degrees. If I was going to talk about this in terms of radians, it's pi radians. So if half of a circle is pi, if half of a circle is 1 pi, then going all the way around a circle would be 2 pi. So if we're talking about radians, half of a circle is pi, all the way around a circle is 2 pi. And we're going to work on splitting up this circle into radians more. And then we're going to work on converting from degrees to radians and all of that. Now, back up here. When we measured out 1 radian, remember how I said to kind of estimate how big of an angle you think that is? And a lot of people are going to probably estimate that as about 60 degrees. And you would be very close. 1 radian is about 57.296 degrees. So a little bit under 60 degrees. And a radian, again, is just another unit to measure angles. Just like if we were using a ruler, we could do feet or inches or centimeters or miles. It's just another way to measure an angle. So I can use degrees or I can use radians. 1 full circle is 2 pi radians. Remember, we talked about half of a circle is pi radians. And then down here, if you're measuring an angle in degrees, you have to have a degree symbol. So if I leave an answer of 30, now that we've talked about radians, that is going to be assumed to be radians, 30 radians. And 30 radians does not equal 30 degrees. They do not equal the same thing. So if you mean to say degrees, you got to put a little degree symbol. Otherwise, it's going to be assumed to be radians. Okay. All right, so we're going to practice converting between degrees and radians. So if I want to go from radians to degrees, this is what I'm going to do. Multiply by 180 over pi. I would write that down. Stop this video and write that down. So here is an example of what radians are going to look like. They're going to involve pi. Again, remember we talked about how half of a circle is pi. So when you see a radian, they're often going to be in terms of a fraction of pi. So if I have this radian and I want to convert it to degrees, I'm going to multiply by this conversion right here, 180 divided by pi. Now, we are multiplying fractions, and remember how we just got done talking about how if I am multiplying by the same thing on top and on bottom, those will cancel. So really, this is the same thing as 3 times 180 over 5. Type that in your calculator, and you're going to get 108. So that would be 108 degrees. So make sure you put the degree symbol on there. 108 degrees, if we were going to graph that, well, remember we would start here at the positive x-axis. This is a positive angle, so I need to go counterclockwise. This is 90 degrees right here. So 108 would be a little bit past that. So that's about 108 degrees. Okay, if I have 3 pi over 4 radians and I want to convert to degrees, again, I'm going to multiply by 180 over pi. And the pi's are going to cancel since I'm multiplying by pi on top and on bottom. So then I'm left with 3 times 180 over 4. And when you type that in your calculator, you get 135 degrees. And I've already graphed this one out, but 135 is 45 degrees more than 90. So that would put me 45 is half of 90. So if this is a 90-degree angle right here as well, I'm going to split it in half. So here's 90 plus 45 more. That's 135 degrees. Okay, now if I want to go the other direction and go from degrees to radians, I'm going to multiply by pi over 180. So stop this and write this down. You'll notice that it's like the exact reciprocal of this. So now the pi is on top and the 180 is on the bottom. And again, this is if you want to go from degrees to radians. So if I have 200 degrees and I want to convert to radians, I'm going to multiply by pi over 180. Now here we need to be just a little bit more careful. This is technically over 1. So if I multiply straight across the top and I multiply straight across the bottom, here's what I get. Now what I should always do is reduce. So I'm going to reduce the number part of this. So I'm going to still have a fraction. There's still going to be a pi on the top, but I'm going to reduce the 200 over 180. Now, if you type in 200 divided by 180 in your calculator, you're going to get 10/9. So 10 pi over 9, 10/9, and then a pi on the top. That is what it will look like in radians. I'm going to do the same thing over here. If I have a negative 45 degrees, I'm going to multiply by pi over 180. To convert it into radians. And then I'm going to smush the two together because I'm multiplying. And remember, this is over 1, so I can multiply straight across the top and straight across the bottom. And now I'm going to reduce. The pi is on the top, that stays there. All I'm reducing is the number part here. So if I type in negative 45 over 180 in my calculator, I'm going to get negative 1/4. So this will be negative 1 pi over 4. And I could just say negative pi over 4 if I wanted to. Either one of those is totally fine. So on your homework, you're going to have to go back like this, convert from radians to degrees, or from degrees to radians. And then here's the last thing. I want to just kind of go through how to convert degrees into radians in a quick way. So remember, you already sketched this from before. So here's how I would look at this, okay? We talked about how 180 degrees is pi. So this is 1 pi. Now do you see how this top half right here, this top part, is 1 pi and it's split into 1, 2, 3, 4 pieces. So if this is 1 whole pi and this is 1/4 of that chunk, then this would be 1/4 of pi. Pi over 4. 90 degrees, do you see that's halfway to pi? That's pi over 2. Half of pi. So if this is 1/4, then this is technically 2/4. 2/4. That would reduce down to 1/2. So I'm going to use the reduced version of it. So this is 1/4, this is 2/4, so this is 3/4, 3 pi over 4. Then technically this would be 4/4, but 4 over 4 is just 1. That's why we would say pi. So we got 1/4, 2/4, 3/4, 4/4. That means this is 5/4. Then this would be 6/4. Now that can reduce. This will reduce down to 3 pi over 2 because 6/4 reduces to 3/2. So we're going to refer to it as 3 pi over 2, the reduced version. Okay, so 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. This would be 7/4. And then this would technically be 8/4. But 8 over 4 reduces down to 2, so this is 2 pi. 1/4, 2/4. Maybe I'll do it right here. So we use the reduced version. 3/4, 4/4, we use the reduced version. 5/4, 6/4, 7/4, 8/4. So that is going by fourths all the way around. Okay, and then I want to show you this version. And you hopefully already had this drawn because I told you to pause it before, but if you didn't do it now. Okay, so again, 180 degrees is pi. Now look at how this is divided up. It's divided up in 1, 2, 3, 4, 5, 6 chunks. So this is going by sixths. So this is 1/6. Then this would be 2/6, which reduces down, 2/6 reduces down to 1/3. 1/6, 2/6, this would be 3/6, which reduces down to 1/2. So then this is 4/6, which reduces down to 2 pi over 3. So this is 5/6. This would be 6/6, which reduces just to pi. This is 7/6. This would be 8/6, which reduces down to 4 pi over 3. This would be 9/6, which reduces down to 3 pi over 2. This would be 10/6, which is going to reduce down to 5 pi over 3. So then this is 11/6, and then this would be 12/6, which reduces down to 2 pi. So you might want to have these kind of written down as a good, easy way to figure out the conversions between degrees and radians, because these are common angles that we're going to use a lot. All right, that is it for today. Have a good one.